Hi, welcome to Turkish Engineering. In this lecture, we are going to solve some projectile motion problems. Let's start with the simplest example. So here, I'm hitting a baseball, okay? So it will has an initial velocity, which is 37 meter per second. Our initial velocity, you can say that it is v sub 0 or v sub I, v initial, which will has quantity or magnitude of 37 meter per second. And my angle, which is initial angle, which I'm hitting with this angle, is just 53.1 degrees. So it's asking for the ball's position and the magnitude and direction of its velocity when time equals to 2 seconds. And when the time ball reaches, find the time the ball reaches the highest point of its flight. So it's asking for T max. And find its height at that point. So it's asking for h max, which is delta y max. Find the horizontal range r, the horizontal distance from the starting point to the point where the ball hits the ground. So let's draw the path to understand the idea more. Actually, I will assume that this guy is hitting this ball just from initial length, which is 0. Okay, so I will neglect the height of the guy. I will neglect. So you can say that actually yi is equal to 0. Okay. So it will go up. So I will just draw the path. And hit the ground. So you can say that when here also y final equals to 0. Okay, so I'm neglecting the height of the guy. So it's asking for the range, which is from here to that point. This is the range. Okay, range of the projectile motion. This is the range, and let's say this is our highest point. So it's asking for the horizontal, the vertical distance from there to the ground, so which is h max, and it's asking for the time when it reaches to maximum height. So this is the idea. Let's start by part A. I must solve for part A. When times equals to 2 seconds, find velocity components. Actually, initial velocity in x will be equal to final velocity in x. It's always. So you can say that our Vx when times equals to 2 seconds will be initial height, which is V cosine theta. Okay. So I know V, which is the magnitude of the resultant velocity. It is not x magnitude and it is not y magnitude. How can I calculate the magnitude for the x component? So it will be just 37 meter per second multiplied by cosine of our angle, which is 53.1 degrees. So I will solve for Vx. It's just 37 meter per second multiplied by cosine of 53.1. So I will get 22.2. It's our initial velocity and actually the final velocity for when time equals to 2 seconds. What about the y? Our y velocity when times equal to any second, I can calculate it by this formula. Initial y plus or minus, you can say, because our acceleration will be in minus direction. So this is our formula. I must calculate v initial y first. Actually, it will be v cosine. I use this one, v cosine. So now I will use v sine theta to give me the component of the velocity at this point. Let's zoom. So this is Vx and this one is Vy. Okay, so I'm asking for Vy. Since it is the opposite for the angle, opposite to the theta, so I will use sine. And since the x is adjacent, so I will use cosine. So sine of 53.1 degrees. So let's calculate here. Instead of cosine, I will put sine. So you will see that our velocity has changed and actually decreased. So I will put 29.6. I can say 29.6 meter per second. So it's asking in part A, magnitude and direction of its velocity. Actually, neither this and this is not velocity of the ball. Actually, the ball is going with a velocity in its direction. So let's say that our ball is here. So it will go with a velocity which in this direction, in two-dimensional. So how can I calculate the resultant of V? As you know, we have just simple formula which is coming from Pythagorean theorem. So I will put Vx squared plus Vy squared, which will be equal to 22.1 squared. Actually, let's remember our cosine. 22.2. Actually, I remember that I made a mistake here. I will put 22.2. Yes, 22.2 squared again plus 29.6 squared, and in a square root I will get the magnitude of the velocity. So put 22.2 squared plus 29.6 squared, you will get the answer, which is this one. Okay, I made a mistake here. Actually, I found 37 meter per second, which is our initial velocity. I put here initial component. Actually, I must use the final one because I'm asking for velocity when times equal to 2. So this one, our initial velocity only. How can I calculate the final y? I must use this one minus 9.8 multiplied by 2 seconds because I have 2 seconds here. So I will use this formula, minus 9.8 multiplied by 2. So I will get 10 meter per second. So here, instead of this one, this is initial y. Actually, I must use the y velocity when time equals to 2 seconds. So I will get different value. You will see that our velocity has decreased. Let's see what's the solution. Actually, this the result of this will be just 24.3. 24.3. So this is our answer. What about the angle? Actually, angle can be calculated by inverse tangent of Vy divided by Vx. So I have the final Vy, which is just 10 meter per second, divided by initial x, or final x, actually they are equal to each other, which is 22.2. So let's take the arctangent, 10 divided by 22.2, I will get the angle. So actually when I reach here, as you see, our angle has displaced. So this one, initial angle was this, and I have now just 24.2. Here I will have 24.2 degrees. So it's the part A. What about part B? Find the time when the ball reached the highest point. Actually, this is easy because I know the formula. T max will be equal to initial velocity in y just divided by the g, which is the gravitational acceleration. I calculated this one as 29.6, which is here as you see, divided by 9.8 will give me, actually it will be very near to 3. So I will say that this is 3 seconds. Okay. This is the first part of part B, and it's asking for the height. How can I calculate the height? As you know, there are two formulas. I will show that the two formulas will give me the same solution. Delta y max, they are equal to, from the first formula, I will use V initial y times, and I must put out maximum time, minus 4.9 times squared. And this 4.9 coming from half of the acceleration. So, and I must put T max. So here take our initial y, which is 29.6 multiplied by maximum time, which is just 3, minus 4.9 multiplied by time squared, which is 3 squared. So I will get 44.7 meters. What about the other one? As you remember, it was just v initial y squared divided by 2g, which is 19.6. So let's try to see if they are equal to each other. What's initial y? Take square of it, just 29.6 squared divided by 2g, which is 19.6. So you will get 44.7. As you see, they are equal to each other. So you can use both of these formulas. Let's move to the part C, because now it's asking for the range. How can I find the range? Actually, for finding the range, as you know, we have a formula which is delta x max will be equal to initial velocity in x time times total time. But I don't know what's total time, so I must find what's total time first. It's actually 2 times maximum time. Actually time max is the time when projectile reached the highest point. So I calculated this one, it is just 3. So 2 times 3 will give me 6 seconds. So the range will be our maximum displacement in the, which is 22.2 meter per second. And I know the time, which is 6 seconds. So seconds will cancel each other, and I will get the solution. So put 22.2 multiplied by 6, you will get 133.2 meters. So you calculated this one, range, and this one. Okay, so actually the question is over now. We will move to the next question.